Hello class, today we are going to be carrying out the separation of a homogeneous mixture of methylene blue and fluorescein using column chromatography. Now, as you can see from the structures of fluorescein and methylene blue, you can see that fluorescein is more polar than methylene blue, and the reason, of course, has to do with the intermolecular forces that are at play in fluorescein. You can see that fluorescein has hydrogen bonding and dipole-dipole interactions and London dispersion, while the methylene blue only has dipole-dipole and London dispersion. And this difference in polarities is very, very important because it ensures that separation is achievable. Remember, when we talked about column chromatography, we talked about the fact that um, separation is achieved by the selective adsorption and desorption of components on the stationary phase as the mixture travels down the column. And so you will see that because the fluorescein is more polar, it's going to be retained longer on the column and it will elute much later. Okay, and because methylene blue is less polar, it's going to be retained shorter on the column and it will elute earlier. The reason because is that methylene blue, being less polar, doesn't cling as tightly to the column as fluorescein, which is more polar. Fluorescein, being more polar, is going to cling more tightly to the stationary phase of the column, and so it's going to be retained longer on the column, while methylene blue is going to be retained shorter on the column. And so this is how the separation is achieved, by taking advantage of the difference in polarity between fluorescein and methylene blue.